Now if a line, over a line M, if a line touches a circle at a single point, then it is said to be the tangent of the circle. And the point of contact over here is what? P. So P is a point of contact of the tangent M to the circle. Now if the line N, if any line intersects the circle at 2 points, that is point Q and point R, so it is intersecting at 2 points, then it is said to be secant. So you should know the difference between tangent and secant. Tangent touches the circle at a single point, and secant touches the circle or intersects the circle at 2 points. Now next is tangent theorem. Now what is tangent theorem? A tangent at any point of a circle. So a tangent at any point of a circle is perpendicular to the radius at the point of contact. So OA is a radius and tangent L is perpendicular to this radius. So we have to prove this tangent theorem. So given line L is a tangent to the circle with center O at the point of contact A, we have to prove that line L is perpendicular to OA. Now this is an indirect proof. So let us assume that OA is not perpendicular to line L or tangent L. So we will take OB perpendicular to line L, that is tangent L. Now take a point A. Take a point C such that AB should be equal to BC. That means AB should be equal to BC and A dash B dash C. That means they are collinear point. Now if you take this two triangle, AB is equal to, so in triangle OBA and triangle OBC. So this two triangle. Now AB is equal to AC, that is not AC, BC construction, and angle OBA is congruent to angle OBC. Each measures 90 degree, and OB is congruent to OB. OB is congruent to OB by common side. Therefore, triangle OBA is congruent to triangle OBC. By which test? SAS test. By SAS test. Therefore, OC should be equal to OA. Why? Congruent sides of congruent triangle. That means OA is radius. We already know that OA is the radius. Therefore, OC should also be radius. So that means tangent L, OA and OC. OC and OA is a radius. That means point C should be on the circle, point A should be on the circle, and line L is touching the circle at 2 points. That means it is touching the circle at 2 points, but we know that tangent intersect the circle only at 1 point. So our assumption that OA is not perpendicular to line L is wrong. OA is perpendicular to line L. Now on page 52, they have asked a question: which theorems do we use in proving that hypotenuse is the longest side of a right angle triangle? We know that in a right angle triangle, the hypotenuse is always the longest side in a right angle triangle. That means AC is the longest side. Now in a right angle triangle, this is 90 degree, and these two, angle A and angle C over here is our acute angles. Acute angle. What is the meaning of acute angle? The measure of acute angle is always less than 90 degree, and angle B is equal to 90 degree. So which is the greatest angle? Angle B is the greatest angle. So we had studied last year the side opposite to the greatest angle angle is the longest. So angle B is the greatest angle, and the side opposite to that is what? Hypotenuse AC. So hypotenuse AC will be the longest side. Now the next theorem, converse of tangent theorem. What is the theorem? If a line is perpendicular to the radius. So if a line is perpendicular to the radius at a point on the circle, then it is a tangent of the circle. So given over here, M is the center of the circle, segment MN is the radius, and you have to prove that line L is a tangent to the circle. Now take a point P on the tangent or the line L and join M and P. Now this is a right angle triangle because we know that radius is perpendicular to the tangent, so it's a right angle triangle, and MP will become the hypotenuse. So segment, since it is a hypotenuse, so segment MP will be greater than segment MN. Now MN is a radius, we know that MN is a radius, segment MN is a radius. Therefore, point MP will be greater than the radius, therefore point P does not lie on the circle. The point P is lying in the exterior of the circle. So on the tangent, that is on line L, except N, no other point is on the circle. So the line L intersects the circle at only one single point. Therefore line L is a tangent to the circle. Now next is tangent segment theorem. Before I start this tangent segment theorem, let me explain this. Now if the circle is there and you take any point on the circle, let us take point P on the circle, then how many tangents can you draw? Only one tangent you can draw from a point of contact on the circle. Supposing if I take a point outside the circle, then how many tangents can you draw from a point outside the circle? Two tangents can be drawn from a point outside the circle. So if a point P is outside the circle, then how many tangents can you draw? Two tangents can be drawn which touches a circle at 2 points. Now tangent segment theorem. Now what is this theorem? Tangent segments drawn from an external point to a circle are congruent. That means if this is an external point, then the tangent segment which is drawn from the external point are congruent to each other. That is PD is congruent to QD. We have to prove that. So given A is the center of the circle, tangents through the external point D touches a circle at point P and at point Q. You have to prove that dP is equal to dQ, is congruent to dQ. Construction. Now I have shown the construction in the red line. So this is a construction. Draw segment AP and AQ. Now in triangle PAD, that is this two triangle, in triangle PAD and triangle QAD, PA is congruent to AQ. Segment PA is congruent to segment QA. Why? Because they are the radii of the same circle. So PA is equal to AQ. So PA is 3 centimeter, then AQ also has to be 3 centimeter because they are the radius of the same circle. Now segment AD is congruent to segment AD. Why? Because they are common side. So this is a theorem given in the textbook. You have to fill up the boxes of blanks which is given in the theorem or proof. Now angle APD, that is this angle. Angle APD is equal to angle AQD. Why? Because it is equal to 90 degree. What is the reason? Tangent theorem. So what is tangent theorem? Radius is always perpendicular to the tangent at the point of contact. Now triangle PAD, that is this triangle and this triangle are congruent to each other by hypotenuse side theorem. This is a right angle, so this is the hypotenuse which is opposite to that. Therefore the two triangles are congruent to each other by hypotenuse side. That is the other one side we had proved, that is a radius of the circle. So hypotenuse side theorem. So why segment now? Therefore segment DP is congruent to segment DQ. What is the reason? CS CT, that is congruent side of congruent triangle.